And now we're on location at the Johnson Space Center here to talk with Monica Visinsky, Public Affairs Officer Brandi.
Hi, welcome to Building 9, the Space Vehicle Mock-Up Facility here at Johnson Space Center. And as Miko said, we have with us today Monica Visinsky, who is going to be telling us about a test that's going on here in the background. Why don't you kind of take it from the top on what we're doing here?
What we're doing here is we are testing a airlock transfer device that we've developed. So the Japanese module has a airlock that has a sliding table that they would use to extend out experiments. They've used it in the past to send out their small fine arm. And what we're going to use it for is we're going to use it to bring spares that are internal in the pressurized volume outside so that the Dextre robot can access it and use that spare in maintenance activities.
Okay, so what we've got behind us is the trainer that's used for the special purpose Dextre manipulator, or Dextre, which is what we normally like to call it. But and that's used already to change out spare parts or ORUs, orbital replacement units, right?
Yes, we've actually already changed out this little tiny ORU, which is the remote power controller module. So we've done that repair on orbit. And in the testing here, we're testing all sorts of ORUs, including this small one and the big one that you see that they're maneuvering around back there, as well as a variety of different shape ORUs or boxes, and different configurations of those boxes.
So kind of the problem we're trying to solve here is we have the spare parts inside the station and we want to get them out or bring failed ones in, right?
Right. With the retirement of the space shuttle, we don't have a lot of EVA capability anymore.
Spacewalk, yeah.
Spacewalk capability. So this will enable us, in fact, they only have one spacewalk per year. And if the spare is inside, the robot can't get at it. So what this will enable us to do is to bring those spares outside. The robot can use them to do the maintenance activities throughout the year, not requiring the crew to come outside.
Okay.
Saves on time.
So how will it work? I think
well, what happens, I have this is a half-scale mock-up that we have. And I will hand that to you.
Yeah.
So inside, the crew in their shirt sleeves would assemble the transfer interface, which is really a glorified clamp. And this, the silver part represents the airlock table.
Okay.
So they would have it, they would assemble it, they move the walls into position based on the ORU or the box that's going in it. This is a little Canadian mock-up box that we're using here, again, half scale. And they would put the spare into the system and then they would close the clamp.
Okay.
This would then extend outside. And once it's outside, the Dextre robot would fly in, would grab the grass fixture on the box, and then inside the crew would flip a switch, which would automatically pull this back, and then the robot would pull that away and then go use it in a maintenance activity.
Okay. So that seems pretty straightforward.
Yes.
So what are y'all working on here today? Why do you need to practice it, I guess?
What we're testing here today is we're still in the design phase. We're past the preliminary design and working towards the critical design. And what we're testing is the ability of the operators to use the visual cues that are on the device and the natural features of the boxes to see if they can actually align enough to get it in there to make sure that it's encaged when it's closed.
Okay. So I guess for people who watch NASA TV a lot, when we see the robotic operation, it usually has kind of a bullseye or target on it that it uses to pick it up, right?
Right. And in this case, we don't. Because for one, when you're going to insert the ORU, there's a lot of times the end effector, the end of the arm, is looking at the box itself. So it can't see anything around it but the box. We're using the external cameras, a couple that are on the robot itself, on the large arm, and ones that are on station and on the Japanese facility to look at the work site. And all of those cameras are positioned where they are. So they may be at a slight angle to the work site or looking like over the shoulder of the robot, so the robot's partially blocking the view. So what we're testing here is whether the operator can still interpret the cues correctly to get the box into the center.
And you've been doing a couple of weeks of testing now, right? How's it going?
Yeah, we started last week. It's going pretty well. We've had some learning experiences as we've gone. We've actually added some visual markings onto the various pieces of the interface to help improve their ability to align and see the information that they need to see. And we've had some more interesting experiences. We had one box that's actually a very large box. We don't actually have a real representation of it here. We're using the one that we have in the grippers right now as a volumetric representation of it. But it's so big that it has a very tight clearance when it goes into this interface. So what we end up doing is aligning very precisely up at the top and coming in. Mm-hmm. And there was one run where he thought he couldn't tell based on the views. So he actually stopped above and said, I can't go any farther.
Oh, really?
Yeah.
Okay. So so there's few things to work out, I guess,
yes.
before it's probably still a while before you get it up on orbit or anything.
Well, actually, they're planning to launch it at the beginning of next year.
Oh, okay. So not so far away.
Yeah, not so far away.
Is that pretty exciting to be working on something that's going up into space?
It is, actually. And actually, the immediacy of it is exciting, too. We already have people that want to use it.
Oh, yeah?
Payloads that want to use it to bring out new components or
mm-hmm.
swap out components on their payloads to extend their life.
Yeah, I bet people can think of a lot of uses for that.
Yeah.
And it's good. We were talking earlier about having ways we're finding to use that airlock, right?
Yes.
And I guess it's pretty international.
It is very international. So the airlock itself is the Japanese. The robot and all of the robots are Canadian, and
mm-hmm.
then NASA is helping with the design of the system itself. So.
Is that interesting, working with all those different parts?
It is.
Yeah.
It's very. All of the groups are very intelligent and very, very good workers, I guess. It's always been nice to work with all of them. So,
well, what's the next step for y'all?
The next step is actually that critical design review that I mentioned earlier. So once we get this testing finished, we will evaluate from all of the testing what cues we really want to implement, mm-hmm. and we will work that into the design and then aim for the critical design review, and hopefully at that point we will hand it over and be able to manufacture it and build it.
Well, good luck. We really appreciate you telling us more about this.
Thank you.